Hi guys, there was a question on one of the problems in quiz number 3. The one I just gave it back. I gave back to you. So it was problem number 10. So we have an infinite series, n equals to 1 to infinity of the ln of n over n quantity square. Okay. So you were asked, of course, to decide if this series converges or diverges. So we're going to apply I think they also asked to use the limit comparison test. So you can try to compare this to maybe 1 over n squared, some of the so-called p series like n squared here. So if you try that, what happens? Your limit becomes infinity, which of course doesn't help because 1 over n squared is a convergent series. So then we're going to try to go a little bit lower than 2 and see if that works. So basically we're going to look at the limit as n goes to infinity of our function. I'm going to go ahead and square top and the bottom. So we have ln of n squared over n squared. And then we're going to divide all that by 1 over n to the 3/2. Okay, so now notice that 1 over n to the 3/2, of course, still a p series, and also it's convergent because 3/2 is more than 1, greater than 1, okay? So we're going to find this limit as n goes to infinity. Basically, what's going to happen, of course, as you reciprocate this to multiply by top, you're going to get an n to the 3/2 up here, of course, over 1. So now, we're going to basically reduce this. So what's going to happen again? It's going to become natural log of n squared over, now you have n to the 3/2. This is n squared, which is of course 4/2. So that leaves you with the n to the 1/2 down here. Okay, so now I'm just going to tell you what's going to happen. Of course, next is that as n goes to infinity, again you get infinity over infinity. So now you apply the L'Hopital's rule. And actually, you're going to have to apply it, I think, 2 or 3 times. So I'm going to let you check that yourself. So you're going to keep differentiating top and the bottom. So ultimately, what's going to happen as you do 2 or 3 application of L'Hopital, I think you're going to end up with, because I worked it here, you're going to end up with basically limit as n goes to infinity of 8 over n to the 1/2. Okay? So that's what's going to, as you keep differentiating the top and the bottom, because you're going to keep getting infinity over infinity, and then finally you're going to get this expression. Of course, as n goes to infinity, the bottom gets larger and larger, so the whole thing goes to 0. And so by the limit comparison test, because the limit, of course, is 0, you have a convergent series. Okay, so this series converges. And I believe it actually converges absolutely anyway because it is always positive. So it does converge, okay? All right, I hope that helps.